Hello. Today we are going to continue in our proving or in our parallel lines unit, and we are going to prove lines are parallel. What we have previously looked at, or in the last section, we were provided parallel lines, and based on parallel lines, we were able to find various angle relationships like corresponding angles are congruent and so forth. Today we are just provided two lines cut by a transversal, and we're trying to show that they're parallel if we can. So that's why this section is called Proving Lines Parallel. So we have four, they're actually called converses because they are truly the converse of the theorems from the last section. So for example, let me go back to the last section. If I start with the corresponding angles postulate, so it said that if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So if I were to go back and write the converse of this statement, I would switch around the hypothesis and conclusion. So it would read something like this. If pairs of corresponding angles are congruent, then the two lines are parallel. So that's what we're looking at today. We have the exact converse of the four theorems from the last section. So I'm going to highlight these because they are going to show up in a proof or in proofs as you work. And so it's going to be important that you know the name. So this is called the corresponding angles converse. It says if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So if we really condense that down, if corresponding angles are congruent, then lines are parallel. So notice in your diagram, the lines are always going to be shown to be parallel. We can't go by the way it's drawn. There are no parallel marks here, so I can't assume that. So this diagram is trying to show me, hey, I've got these two angles here with these arcs on them, and they're sitting in corresponding positions. So since they're congruent, therefore the conclusion is this, that J is parallel to K. All right, so it's the reverse, which is the converse, of all of the postulates and theorems from the last section. Okay, and if you look ahead, we have the alternate interior angles converse. Okay, we've got the alternate exterior angles converse, and then the consecutive interior angles converse. Okay, and so they all basically say the same thing. Alternate interior angles converse, if I summarize here, if alternate interior angles are congruent, then lines are parallel. And so notice your diagram is giving you a pair of alternate interior angles that are shown congruent with the arcs. Lines are parallel. In the next one, alternate exterior angles, if they're congruent, then lines are parallel. And then remember, on consecutive interior, the angles are not congruent. So it says here, if I kind of skip past the two lines, if consecutive interior angles are supplementary, then the lines are parallel. So I'd either have to be able to add these two together to verify that they add up to 180, or I would have to be given some information that would say, you know, angles 3 and 5 are supplementary. What can you conclude? Okay, so what we're going to do today on many of these, oftentimes these are the answers. So if we have a question that says, can you determine if the lines are parallel? If so, explain. And so then these theorems are often our explanations. Okay, let's take a look at these three examples here. Is there enough information to prove that L is parallel to M? If so, state the postulate or theorem. Now, these up here, even though they are called, they end in the word converse, they are still postulates or theorems. So the corresponding angles converse is technically a postulate, and then these are theorems. All right, so we're just gonna quote what we highlighted here. All right, okay, let's look at 4 congruent to 8. So I'm gonna use a pencil here so I can erase it for the next couple examples. All right, so 4 is this one, 8 is this one. So these two are congruent. Can I prove the lines are parallel? Well, yeah, 4 and 8 are corresponding, and so the corresponding angles converse says if your angles are corresponding, then your lines are parallel. So is there enough information? Yes. If so, state the postulate or theorem. So I'm going to say here yes, and then the reason is the corresponding angles converse. Corresponding angles converse. Okay, and that's it. That's the answer to our question. So we're just trying to do some recognition here on these. Okay, 2 is congruent to 7. 2 is up here, 7 is here. Okay, so I need to recognize these are alternate exterior angles, and based on the converse above, if they're the same, then the lines are parallel. So yes, we can, with that information, prove it. And my reason is going to be alternate exterior angles converse. Alternate exterior angles converse. Okay, 6 congruent to 7. 6 is right here and 7 is right here. Okay, well, what I do see is that 6 and 7 are vertical angles, okay, and I know vertical angles are congruent, so that is true. But does 6 being congruent to 7 help me see that L is parallel to M? And it doesn't. Notice 1, 2, 3, and 4 must be included in what I'm given in order to use one of my converses. So I'm going to say here, is there enough information? No. And then I'm just going to elaborate a little bit and say something like vertical angles do not create parallel lines or something like that. Vertical angles, or you could say vertical angles do not guarantee lines are parallel. Vertical angles do not, I'll just say create parallel lines. Okay. All right. Okay, let's go on to the next page. All right, looks like we're going to do a little bit of solving here. So let's find the value of x that makes M parallel to line N. So what would x be in order to be parallel? So what the kind of the thought process here is, so 2x plus 1 is this angle right here, 3x minus 5 is this one. So if I can get those two angles to be the same, then by the alternate interior angles converse, the lines are parallel. So I want to know what value of x makes these two angles the same. So I need to just set them equal to each other and solve. So 2x plus 1 equals 3x minus 5. Okay, we just solve from here. I'll take away 2x. Doesn't really matter if this is your next step or not. So 1 equals x minus 5, and then, oops, move the 5 over. So looks like I get x equals 6, or 6 equals x. Okay, and that's all we need to do. It doesn't say to explain why. If it did, I would go ahead and talk about the alternate exterior angles converse, but I just am solving for x on this one. All right, let's look at the next one. Is AB, I should probably have a line symbol above that. Let's add that. Is line AB parallel to line DC? And is AD, let's add these lines here, parallel to BC? Okay. Is AD parallel to DC? So AB and DC. Okay, what do I have? I want to look for some equal corresponding angles. Or maybe I have some equal alternate exterior angles or something in that respect. So when I look at this, I see that this is what's jumping out at me. You see this 65, I'm going to put an arc here, and 65 here. So if I were to, sometimes it helps to kind of extend these lines out. Here's your transversal. So these 65s are alternate interior. So since they're the same, it is forcing these lines to be parallel. So yeah, those two lines are parallel. So I'm going to kind of answer this one here. I'm going to say yes. And it doesn't say to explain, but let's add that. So that is parallel by the alternate interior angles converse. I'm going to say here by the alternate interior. If you want to abbreviate just a little bit, you can. Alternate interior angles converse. Okay. Okay, so we have those two parallel. Now we're looking at AD, which is are these two lines here, AD and BC. So let's see what we got here. All right, I see a transversal right here. Okay, so I've got 65 here. All right, and it looks like I have 65 here. So the problem with that, let's see, if these are my lines and my transversal, 65 is really on the wrong side of the transversal to be alternate interior. If I had a number here and a number here that were the same, then I could quote alternate interior. That's not going to work. Let's see, I'm going to resketch this. These are the vertical lines I'm looking at. So I determined that this transversal wasn't going to help me because I don't know what's going on this whole angle or this side. What about the other transversal? Let's go this way. So I have 40, but 40 is only partially right here. So I don't know this one. And then I don't know what's going on over here. Let's try the horizontal line up there. So I'm going to use these two. These are the two parallel lines I'm trying to see. Let's see if this transversal helps me. So this is, I have 155 and 115 here. Well, these are corresponding angles, but they're not the same. So, and this diagram is obviously not drawn to scale. So if these were the same, I would say yes, they're parallel. So I'm gonna have to say no, they're not parallel, and it really fails by this corresponding angle area. So let me go like this. I'm gonna say here no, and then I'm just gonna say that the corresponding angles are not congruent. Corresponding angles are not congruent. Okay, so feel free, like I did here, draw a picture and get rid of all the extra stuff that isn't necessary for that particular thing that you're looking at. Okay, let's go through this next example, and then let me see. We do have a couple proofs, so I will do a second video for the proofs. Okay, let's find the values of A and B such that P is parallel to Q. So I'm trying to force P parallel to Q by thinking about what things could be equal. All right, so I have vertical angles I see here. Okay, those are equal. What else do I know? So if I had parallel lines, these two are consecutive interior angles. If the lines were parallel, or if, let me rephrase that. If these two angles were supplementary, then I know the lines are parallel. Let's see what else. It's really kind of about all I can work with. So I'm going to write those two ideas down. I'm going to do the vertical angles first. So 8A minus B is equal to 2A plus 3B. Oop, not B. That's supposed to be a B, not a 6. Okay, let's write the second one down. I'm going to write these as supplementary. So 2A plus 3B plus A plus B is equal to 180. All right, so I think what I need to do here is kind of rearrange them so that the A's are in a column, the B's are in a column, the equals are together and numbers. So I'm going to do kind of wrap all that up in one step here. So I am going to, I've got A and B. I'm going to move this 2A over here under the 8A and the 3B over here minus 3B. and combine terms together. And let's write that equation there. So let's say I take away 2a from both sides. That would be 8 minus 2 is 6. So that leaves me with 6a. So minus 3b minus 3b would make that negative 4. So negative 4b. And that leaves 0 over there. Now I'm going to combine terms. 2 and 1 would be 3. 3a. 3 plus 1 is 4. Plus 180. Okay. So actually, look at the b's. I'm pretty lucky here. They're going to naturally just cancel out. So let's go ahead and proceed. So let's add. 6 and 3 would be 9a. These guys are adding up to 0. 180 divided by 9. So that should be 20. 18 divided by 9 is 2, and then tack on that 0. So I have 20. So I'm going to plug in 20 for a. I like to go back to the top just in case I made a mistake, or you could go here, it doesn't matter. But I'm going to just maybe plug it into the second one. You can plug it into any of them if you want. So I'm going to do 2 times 20 plus 3b plus 20 plus b equals 180. So that is going to be 40 plus 4b plus 20. And actually, I'll go ahead and add those together. So it's really 60 plus 4b equals 180. And then from here, we just solve. Take away 60 from both sides. 120, it looks like. 8 minus 6 is 2. And then divide off the 4. So 12 divided by 4 is 3. And then, since it's 120, it would be 30. All right, so I've got 20 for A and 30 for B. Okay, now I probably should plug them in, plug in A and B here to make sure these angles are the same, and then plug in A and B, make sure these add to 180. That would be a next best thing to check, so. Okay, I'm going to have a second video for the last two proofs we'll look at.